All right, so we're going to start part 3 here of our example problems for exam 2. In this example problem, we're looking at calculating the probability, right, to find an electron in the px orbital in certain regions of space. Okay, right. Theta here is going to just be pi over 2 the entire time, right? And so, and the first step is to actually calculate what the px wave function looks like given this actual definition. Okay, that's related to these spherical harmonics, which are defined here. Okay, so px, right, is equal to 1 over the square root of 2 of y, oh, not y, or psi here, sorry. But of y 1 plus y minus, or 1 minus 1. Okay. All right, which ends up being 1 over the square root of 2 of the square root of 3 over 8 pi sine of theta e to minus I phi plus square root of 3 over 8 pi sine theta e to the positive I phi. Okay, using Euler's relationship, or e to the I phi is equal to cosine phi plus I sine phi. Okay, we get that px is equal to square root of 3 over 16 pi, just using the fact that pulling out the constants here, sine theta, right, of then cosine phi minus I sine phi plus cosine phi plus I sine phi, right? And you see here, right, that the sine terms cancel, and we're just left with 2 times the cosine terms, which then simplifying gives us px equals square root of 3 over 4 pi sine theta cosine phi. Okay, so that is our px orbital, right? It's real valued, which is good. So now we're going to calculate the probability of finding this in a certain region of space. Okay. So to find that probability, right, what I'm looking at is I'm wanting to know what is the probability of finding my wave function here of being between theta equals minus pi over 8 and pi over 8. Right, so between minus pi over 8 to positive pi over 8, right? Sorry, that's for phi, not theta. And that's phi, right? And theta is just pi over 2, okay? Which, again, our wave function here, right, which is p of x, so square root of 3 over 4 pi, sine theta cosine phi, right? Our wave function theta part, right, at pi over 2 is just equal to 1, and we're not integrating over anything, it's just at specifically pi over 2. So we don't need to worry about that because that's just equal to 1. So, right, at this point, this simplifies down to just square root of 3 over 4 pi cosine phi. Okay? So then to do this integral, we have to integrate from minus pi over 8 pi over 8 of psi star psi, which is going to give us an integral d phi here, from minus pi over 8 of 3 over 4 pi cosine squared theta d phi. It's not theta, and often we use theta more than we use phi in classes, so I always think of theta first, but it's phi here. Okay, and so that is the integral we're trying to solve, right? And so at this point, right, if I want to simplify this a little bit, it's just 3 over 4 pi, pull out those constants, right? Then integral of minus pi over 8 of cosine squared phi d phi, okay? So that's the integral we want to solve, right? So there's a bunch of ways you can solve this. You can use trigonometric identities to simplify cosine squared in terms of sines of 2 thetas and things like that, or you can use integral tables, or you can just use Wolfram alpha or something else to try to solve it. Okay, and so if we use just something to solve, right, what you'll find is that this integral comes out to be still you have the 3 over 4 pi, okay, and then it comes out to be pi over 8 plus 1 over 2 square root of 2, okay, right, and so this final probability comes out to be just 0.178, right, or 17.8%, okay, so that's a probability of being located around phi equals 0, right? And so the question we have is, what about the case when we're between 3 pi over 8 to 5 pi over 8, right? It's the value of phi, okay? So it's the same chunk of space, 2 pi over 8. So it's the same amount of degree that we're transitioning between our initial and final values, but now we're centered around pi over 2 instead of 0, right? Which we know cosine of phi at 0 is equal to 1 and pi over 2 equals 0. So we should expect this to be a much smaller number, right? And so again, you're just trying to solve the exact same integral where we have 3 over 4 pi times integral of 3 pi over 8 to 5 pi over 8 of cosine squared phi d phi, right? That's the integral that we get, right? Like we did last time, we're just changing the integral limits, okay? And you again can look up an integral table, look up trigonometric identities, right? Use Wolfram alpha or something else like that to solve this integral, okay? And you're going to get that this is equal to 3 over 4 pi times pi over 8 minus 1 over 2 square root of 2, okay, which ends up being 0.0093, okay. So the probability here is equal to 0.0093, or less than 1%, okay. Right, so less than 1% of the time, you're located at pi over 2 versus being located at pi, right? And that's why, right, this is called the px orbital, right? Because if you plot this in the xy plane, right, this is my x-axis, the y-axis, right, I have a lot of probability of being here and essentially 0 probability of being on the y-axis, right? So this is what I should expect, right? That when I'm looking at the probability, right, somewhere in this area, right, around the x-axis, I should see a lot of probability, but then when I look for the probability somewhere around the y-axis in this area, right, I'll have very little probability around there, okay? All right, so next question here, what is the commutator between these two functions, okay? And we didn't necessarily go over in class too much detail how to do this. There's a homework problem related with finding commutators, right? But basically, in order to find the commutator, right, what I need to do is I need to take this commutator d squared dx squared x squared and act it on some function of x, right? And I just got to find out what the heck does that equal, okay? And as a reminder, this commutator itself is just a simpler way of writing d squared dx squared, x squared, minus x squared, d squared, dx squared. Okay. Trying to make that d look nicer. Every time I try to fix my handwriting, it seems to make it worse. Okay. And so that is what we're trying to solve. So if I'm trying to solve that, right, what I will need to be solving for is what is d squared dx squared of x squared f of x minus x squared d squared dx squared f of x. What does this equal? So let's work that out, shall we? So, right, I have, again, d squared dx squared f of x minus x squared d squared dx squared f of x. Okay. Now, for this section over here, the second term, there's nothing I really can do to simplify this because I just have the derivative acting on some function of x, which is an arbitrary function that could be anything. Okay. So there's nothing I need to do to simplify it. Right. What we need to try to simplify is this term over here. Okay. So working out what that term is. Okay. What I need to do again is like the product rule, chain rule, right? I'm going to do d dx and then d dx. So, right, d squared dx squared is just taking d dx twice, right, of x squared f of x, which is going to equal d dx, right, of dx squared dx times f of x plus x squared times d f of x dx. Okay. And so continuing on, we get d dx, right, of this first term here, right, the first term that we have here, right, this term comes down here, right, and this is just equal to 2x f of x, right, and then the second term is just x squared d f of x dx, right. And so now I need to take the derivative of this thing again, okay, which then this is going to be, right, related to 2d dx of x f of x plus d dx of x squared df dx. Okay. And so simplifying this, right, this first term, right, of d dx of x f of x is going to simplify down to 2 times f of x plus 2x df dx, and then the second term simplifies down to 2x df dx plus x squared d squared f dx. Okay, and so this is my simplified derivative, right, from up above. Okay, this guy is simplified down here, which is not super simple. Okay, but what we can see, right, is that I have this common term here. I have this x squared d squared df, and then I'm going to have minus x squared d squared f dx squared, okay, dx squared, right? So those will cancel with each other, right? And so what I'm left with is going to be 2 plus 2, or simplify it down a little bit more here, right? 2 plus 4x d dx, okay? All of this acting on f of x, okay? And so, right? My final answer here then is that my commutator is just equal to 2 plus 4x d dx, okay? Right, so acting this commutator d squared dx squared and x squared on some function is effectively like just multiplying that or acting on that function with 2 plus 4x d dx, okay? Is what that simplifies down to. And those give the exact same answer for any function of x, right? So we didn't assume any functional form of f, right? We left it completely arbitrary, okay?